So here we have a maximum coefficient of static friction equaling 0.90, and then we have this incline here. So let's draw what's going on. You always want to draw a free body diagram when you're dealing with forces. It makes everything a lot more easier. And this will be a mass. And we have force normal pointing perpendicular to the surface of the incline. We have force of friction going against motion. So here force of friction is actually going up the incline because we want to avoid falling down. So if the direction of motion would be down the incline, force of friction is actually keeping you in place. And then we have force of gravity going straight down, and we have this theta here. We're trying to find theta. So we can say that the sum of forces in the y direction equals 0 newtons, because again, we're not going up or down. We can choose new coordinate Cartesian axis. So these are new Cartesian axes. And this was going to equal 0 newtons. And this will equal force normal minus the y component of gravity. So that'll be mg cosine of theta. So force normal equals mg cosine of theta. And at this point, we can say that sum of forces in the x direction equals 0, because we're trying to make this car stay in place. So we can say that this is equaling force of friction minus the x component of gravity, so mg sine of theta. So we can say that force of friction equals mg sine of theta, and this is going to be equal to mu static f of n, or we can say mu static mg cosine of theta. The masses cancel out, the acceleration due to gravity cancels out, and we figure out that theta is simply going to be equal to arctan of the coefficient of static friction. So tan of -1 of 0.90, and we have a maximum angle of 42 degrees. So anything greater than 42 degrees, and the basically the x component of gravity is going to overtake the force of friction, and the car is going to start sliding down the incline. So again, if the maximum static coefficient of static friction is 0.90, the maximum angle would be 42 degrees. That is the end of the solution. Thank you for watching.